Hello everyone. Now we shall go into the second problem of the projection of solids problems. Now here we have in front of us a question on a square prism. A square prism, 35 mm sides of base and 60 mm axis length, rests on HP on one of its corners of the base. Draw the projections of the prism when the axis of the prism is inclined to HP at 45 degrees and to VP at 30 degrees. So let us look into the criteria which we are supposed to satisfy to obtain the solution. The first criteria is the shape, which is a square prism. Second criteria is the dimensions, that is 35 mm sides of base and 60 mm axis length. Third criteria is it is supposed to be resting on HP. Even more specifically, resting on one of its corners of the base on HP. Then fifth criteria is its axis of the prism is inclined to HP at 45 degrees and the same axis is inclined to VP at 30 degrees. So if anyone has guessed it right, it is another beta angle problem. So let us go into the solution to this question, right? The first step is to draw the XY line. Now we will have to satisfy each of the criteria for this problem. The first criteria is the shape and the dimensions of square prism and dimension of 35 mm axis length 60 mm. So it is supposed to be resting on one of its corners of the base. So what we will do is we will try to draw a square prism with respect to the corner condition. So for that, what I will do is I will take a vertical axis which is perpendicular to the reference line, and I will take a point, an appropriate point, and from that point I shall draw two 45 degree lines on either side, right? So I have one 45 degrees over here and the other 45 degrees over here. So two 45 degree lines I have drawn. I have located the points. So on either side I draw a projection line. Now measure 35 mm. Measure 35 mm, okay, and from this point I shall cut an arc of 35 mm and 35 mm over here, and again from the same point from where the arcs have been drawn I shall draw two more arcs. So now I'll join all these 4 points with proper visible lines and we shall get our first position top view. So this angle happens to be 45 degrees and this angle has to be 45 degrees. This was taken when we were measuring using a protractor. You need not have to mention it. I have just shown it here for your understanding. So let us name the points now. I have my point here. I shall call this point as my A bracket A1, B bracket B1, C bracket C1 and D bracket D1. So yes, so when we draw the diagonals, the two diagonals, we shall get our CG or the axis point, right? So this point I shall call it as O bracket O1. So next we shall show our dimensions of how much? 35 mm. So usually dimensions are preferred to be shown to either one of the vertical edges or horizontal edges, but here we do not have a choice. All the 4 edges are inclined at an angle, so we'll take any one of these points. Now let us draw the projection lines from each of these points and get the front view. So now the total length or the axis length happens to be 60 mm, right? So let us draw an axis of 60 mm. and get our points. So join all these points with proper visible lines and we shall get our front view. So in corner conditions, if you observe, the axis line is not visible in the front view, but the same problem, if it were to be resting on one of its base edges, as seen in the previous problem or question number 1, you'll see that the axis line is very much visible, but here the axis line is not visible, right? Because it is hidden behind the line A1, A bracket A1, right? So this over here becomes my B1 dash, this is B dash, this here is my A dash bracket O dash bracket C dash, this here is A1 dash bracket O1 dash bracket C1 dash. Finally, I have my D1 dash and my D dash, and the total axis length happens to be 60 mm. So everything with respect to the first position has been satisfied. That is the shape, that is square prism, dimensions of 35 mm and axis length 60 mm, and finally it is resting on one of its corners or resting on HP, and we are preparing for the second position, the first position itself, that is it's going to rest on one of its corners of the base. Now coming to the second position, we'll have to satisfy two more criteria, that is it has to rest on one of its corners of the base. At the same time, the axis of the prism is inclined at 45 degrees to HP. So here I have a choice, either I can rest it on B1 dash or I can rest it on D1 dash. That is, I am going to rotate this entire first position either in the clockwise direction like this or in the anti-clockwise direction in this way. So however, I will choose the clockwise direction, and assuming and it's known fact that the axis line is very much parallel to this edge B1 dash to B dash. So what I will do is, I'll start off with B1 dash. So locate the point B1 dash, an appropriate point, and from B1 dash I'll draw a line inclined at an angle of 45 degrees. This process is very similar to what we had done in the previous problem. Now measuring this length of 60 mm, and I shall cut the arc, and from both these points, and this becomes my B dash, and from both these points I shall draw two perpendicular lines, right? So basically we are trying to recreate the first position front view in the second position front view, but inclined at an angle of 45 degrees, right? So draw the perpendicular lines with a projection line. Then after that we can measure and cut the arcs. Now the distance from B1 dash to D1 dash we do not know, but assuming it is, let's say, some x value, I'll take from B1 dash to D1 dash, I shall measure it here and I shall cut the arcs. I think it's going a little beyond the measured points. So this point here becomes my D1 dash and this point here becomes my D dash. So join all these 4 points with proper visible lines and we shall get our second position front view. Now again, B1 dash to A1 dash bracket O1 dash bracket C1 dash, I shall measure again using the compass and cut the arc over here to get my midline. Again, this point I'll draw it with the proper visible light, and from here I shall extrapolate this line backwards. So since we have taken 45 degrees over here, this line will also be inclined at an angle of 45 degrees, right? So this point here is A dash bracket O dash bracket C dash, and this point here is A1 dash bracket O1 dash bracket C1 dash, right? So let us draw the projection lines from each of these points and get the second position top view. the same time, let us draw the projection line from here also. And let us locate the points. So I have my point A1 over here, B1 over here, C1 over here, and D1 over here. Then I have my point A, B, C, and D. So let us identify the hidden lines now. As I told you, the rules to identify the hidden line. So the first step is to join all the outermost points with proper visible lines. So my outermost points over here are A to B, B to C, C to C1, C1 to D1, and D1 to A1, and finally back from A1 to A. So let us join all these points first. The first rule. The second rule is to identify the point or overlapping points closest to the XY line or touching the XY line in the second position front view. So in my front view, I have a point which is closest to the XY line or touching the XY line. So that point happens to be my B1 dash. So any line coming out of B1, will be a hidden line unless it is an outer edge. So there are three lines coming out of B1. The three lines are B1 to C1, B1 to A1, and B1 back to B. All these three lines are not forming a part of the outer edge, so automatically they will become the hidden lines. So join these lines with proper hidden lines. Next, the fourth rule, the last rule is all the other remaining lines will be visible line. That is D to C, A to D, and D to D1. So if you observe over here, B1 to D, this particular portion, it overlaps with both visible and hidden line and visible line. So the preference is obviously given to the visible line. And finally I have my O and O1. So O and O1. So we have finished our second position also. We have satisfied two more criteria. The third position we'll have to satisfy the last criteria, that the axis is inclined at 30 degrees to VP. So yes, this is very much a beta angle problem. So we'll have to apply the beta angle process over here. Right? So let me draw a visible line. A regular reference line which is parallel to my XY line, right? So I think with grids it will be easier for you to draw the parallel line, but I cannot do that. So I have drawn a line over here. This line is parallel to the XY line. So from here I shall draw my third position, right? So it says that the axis is inclined at 30 degrees to VP. So placing it over here, I shall draw a 30 degree line. Right? So after drawing the 30 degree line, I can measure the length of the axis from the first position, which is 60 mm. Keeping it here, cut the arc. And through this point, I shall draw a line which is parallel to the XY line. Now after doing this, come to the second position top view, measure the distance from O to O1. Again, keep it at the same point, cut the arc. Now I have my point O1 over here and my point O over here. So join these 2 points and extrapolate this line backwards up to the XY line. So this becomes my beta, and this was my initial 30 degrees, right? So if there was space for me, I wouldn't have drawn this parallel line first and foremost. I would have drawn it from the reference line or my XY line itself. But since there was a shortage of space, I had to do this. So if you do have space, please go ahead and do that. If you do not, you can draw this parallel line and then proceed, just to save space, right? Now the next step is to recreate the second position top view and the third position top view such that the axis is inclined at this O2, O1, and inclined at this beta angle. Now this beta angle value happens to be as measured from my drawing. It is 47 degrees. So I think plus or minus 1 or 2 degrees is kind of acceptable when people do the manual drawing, right? So let us locate the points now. Now since it is symmetric, I can clearly state that O1 to D1, once I measure, it will be the same length as O1 to B1, O to D and O to B. It will be the same length. So on O1 to D1, I shall cut the arc on both sides. I will get O1 to D1 and O1 to B1. At the same time, O to D and O to B. So locate these points. So I have my point here, which is my D1, my point here, which is my B1, this point here is my D, and this point here is my B. Now again, based on it being symmetric, I'll measure from B to C. Now B to C, once I measure, it will be the same length of B to A to D, B1 to C1, B1 to A1, C1 to D1, and as well as A1 to D1. All these three lines will be equal to each other. So I shall cut the arc over here. Right? Then again, B1 to C1 and D1 to E1. Right. So I have my point A1 here, A, C and C1. So recreate by joining this with proper visible lines. If you are drawing it in the grid sheet, it will be easier for you. So we have recreated the second position top view and the third position top view. However, the axis is inclined at an angle of 30 degrees and we have done the beta angle process. Now let us draw the projection lines from each of these points and get the final position front view, right? So from point A, I have a projection line. From point B, the next projection line. Point C. And my point D. Similarly, A1. I think A1 and D1 are very close to each other, so please be very careful. A1, B1, C1 and D1. Draw the projection line from here. I'm not going to draw from B1 because it's along the XY line already. Right? So we've drawn all our projections. So let us look at the points now. My point A and A dash are meeting here. So this is my new point A dash. My point B and B dash are meeting here. So this is my new point B dash. My point C and C dash are meeting here. This is my new point C dash. And my point D, kindly be careful, D and D dash are meeting here. This is my new point D dash. Similarly, A1 and A1 dash are meeting here. This is my new point A1. B1 and B1 dash are meeting here. This is my new point B1. C1 and C1 dash are meeting here. This is my new point C1. And finally D1 and D1 dash are meeting here. This is my new point D1 dash. Right? Right. So let us apply the rules again. The first rule, join all the outermost points with proper visible line. So my outermost points are B1 dash to B dash, B dash to A dash to D dash, D dash to D1 dash, D1 dash to C1 dash, C1 dash back to B1 dash. So please do not get confused. Don't draw a line from D dash to C dash and C dash to D1 dash, because C1 dash is appearing in inwards. Okay. Second step, identify the point which is closest to the XY line. Okay. In the third position top view. Right. So since it's a square, we should identify only one point, and as per my figure, it is the point C which is closer to the XY line or the reference line as compared to B. You can see there's a difference. C is closer than B. So my point is C. So any line coming out of C dash will be a hidden line unless it is an outer edge, right? So the lines coming out of C dash are C dash to D dash, C dash to B dash, and C dash to C1 dash. So all these three lines are not forming a part of the outer edge, so automatically all these three lines will become hidden lines. Okay. So we have drawn, and the fourth and final rule is all the other remaining lines are visible lines. So the visible lines are B1 dash to A1 dash, A1 dash to B1 dash, and A1 dash back to A dash, right? I think this would have come a little more perfectly had it if I had the grids, but I did not have the grids. So you can see that A1 dash to A dash and is not parallel to B1 dash and B dash. So kind of little crooked. I think somewhere along the line the projection lines are not perfectly vertical or horizontal. But if you are drawing with the grids, it will be easier for you to draw. And finally I have my axis point. So please draw the axis line from O1 dash and from O dash. I have located the points. I have my points O dash over here and I have my point O1 dash. So join both these lines with proper axis line, right? So we have satisfied all the criteria for this question and we have obtained our solution. Thank you for your time.